Welcome, everyone, and thank you for attending the second to last session of the day. As I heard they saved the best for last, that means I must not be the best. I'm close to the best, but no, just kidding. So Mike Friesenegger, as you can see, I work for SUSE, but I am not talking in or on behalf of SUSE right now. Actually, I am working on behalf of, can you see my Open Mainframe socks here? I'm working on behalf of the Open Mainframe project. And actually, yeah, I was showing some leg. I was hoping to get more reaction. Come on. No. But I'm actually the co-chair of the Feilong project, which is one of the projects within the Open Mainframe project. And I'm going to talk to you a little bit about Feilong today as the open source API for ZVM automation. So by a show of hands, who here uses ZVM? Who knows what ZVM is? Okay, well, we got good, all right. All right, who's using it? Who actually gets down to the keyboard and bangs on Dermaint and all that kind of stuff? You know what I'm talking about? All right, well, so we'll talk a little bit about that, and you'll get to actually see ZVM in action and the API in action, because not only do I like to talk about things, but I like to demonstrate things. So, but let me first introduce you to Feilong, the project, and how did we come up with the word Feilong? Well, I wasn't involved in that. Actually, it was John Murtek, along with our friends at IBM, who donated the core of this code to the Open Mainframe project. But Feilong actually is a great word that describes what this project tries to accomplish. Feilong in Mandarin translates to flying dragon or a winged legendary creature that flies among the clouds. Well, we're dealing with hypervisors. We're dealing with the ZVM hypervisor, creating virtual machines, spinning them up, tearing them down, basically on-prem clouds. Feilong gives you the API to start up and manage and maintain an on-prem cloud, or at least gives you the ability to talk to ZVM, which is used to create virtual machines, connect storage, networking, and all that kind of good stuff. So that's the background on the word Feilong. As a project, we have a pretty simple mission. We want to contribute and further develop the RESTful API server that simplifies the interaction with ZVM. ZVM as a hypervisor has been around for decades. It predates any of the Intel-based hypervisors that have been out there since the 90s. 5 decades, as I got a hands up over back there, so thank you. So, but ZVM, to interact with ZVM, you have to actually use a 3270 console. You have to use this thing called Dermaint, or at least that's one of the things that you can do. You can buy third-party products and make it easier and all that kind of stuff, but if you wanted to get down to the nitty-gritty management of ZVM, you've got to get down to the mainframe. You've got to get down to 3270. Well, kids these days are coming out of college, and they're not thinking green screens and 3270 is that cool and sexy. They're learning about RESTful APIs. Now, some people may disagree with me that some kids are gonna like, oh yeah, 3270 is great, but many kids these days that are learning how to develop, they're learning how to use HTTP-based API calls, RESTful API calls, and things like that. So as a project, we want to contribute and further develop what has been donated to the Open Mainframe project. We have already a very strong code base through that contribution by IBM, which also helped name the project. The RESTful API server makes it really easy for those that are not experienced with ZVM to be able to interact with ZVM, and you'll get to see that here in just a moment. And then if your organization wants, you can take Feilong, and you could develop your own infrastructure as a service automation to automate VM creation, to connect networks to these VMs, to attach storage to those virtual machines, and all do that through a RESTful API. A little bit of information about the project itself. So if you want to see the code and where it's at, you just go to openmainframeproject.org/projects/Feilong. That's the homepage for the landing page. You'll see if you go out to that landing page, you'll see a version of this presentation that I did for last year's Open Mainframe Summit. And by the way, these slides are available for you to download, so you can just go and download these slides. I already have them posted up. If you want to look at the code, there's the GitHub link that you can go to, the documentation link. That's an area that I think we need to put a little bit of effort in to help make it a little better. We have a ZVM environment available for project contributions. Today, that environment is provided through Vicom Infinity. Len, back there in the corner, thanks to Len and Vicom Infinity and Vinny, who had to step away, but they actually have set up that environment. And so if there's an organization that needs access to a second level ZVM environment, we have that available to them. Pretty soon, I hope within 2023, with that new shiny mainframe that's part of the Open Mainframe project, we'll be able to actually get maybe even some real LPARs and run ZVM inside of some real LPARs and things like that that are dedicated to Feilong development and enhancing the RESTful API. We have a very global team, and so we started having meetings. We've always had meetings once a month, but they've always been once a month, 9 a.m. North America time. But there's a large contingent of people that are using and developing for Feilong over in Asia. So what we've done is we've gone to this even month, odd month type of rotation. Even months are, 9 p.m. Eastern Daylight Time. Odd months are 9 a.m. Eastern Daylight Time, and which happens to be 9 a.m. for China on even months and 9 p.m. for China on odd months. So we try and be very inclusive when it comes to everybody that wants to join, everybody that wants to contribute. All of the meeting notes, I run the meeting, I take the meeting notes, I email the meeting notes out to our mailing list. This is actually not just a discussion list for receiving the mailing notes, but anybody can ask any questions. You can go to GitHub, you can post an issue there, you can ask the question inside of GitHub, you can ask the question inside of the Feilong discussion mailing list, wherever you want. We're pretty easily accessible, even via chat. Today, I think it's a Slack chat. I know that John Murtek and the TAC, the Open Mainframe Project Technical Advisory Committee, I think they've been talking about changing up and going to a different chat platform, but I don't think that has happened at this point yet. So we have 40 contributors, and like I said, global participation. You may say, well, how busy is this project? Well, just in 2021 alone, from 13 committers, we had nearly 150 commits that have been merged into upstream. So 150 commits that have been reviewed and have been accepted into the mainline part of the project, I guess I should say. The Feilong project is actually used within an IBM product. So not only is this kind of just happening in the community, but IBM is using it in their product called ICIC, or IBM Cloud Infrastructure Center. They're by the cloud, but on-prem like clouds. But we have organizations that are using Feilong outside of ICIC as well. There's a partner who's also part of the project that actually is working with their customer, and they've written their own web-based interface and way to interact with the API for their customer to manage ZVM, to make it easy for that customer to manage ZVM. On average, we have about 5 people attend the monthly meeting. Len is one of them. Vinny is another, myself, a few other people that I don't see in here right now, but we're always trying to see how we can grow the number of people that are attending the session. And I've been the project chairman since the Feilong was started, so that's going on 4 years now. And I announced in early 2022 that, hey, if there's someone else that wants to take over being a project chairman for Feilong, I'd be happy to stay engaged, but I'd be happy to hand off the reins. So something that I want to mention to the group here, to everybody online, if you're interested in getting engaged in an open source project that's growing, we'd love to have you come learn more about it and express your interest of getting engaged with the project. All right, that's enough about the project itself. Let's talk about the technology, because I'm hoping that everybody in here is at some level a technologist, as I am a architect, but I actually can get into the code. I've made contributions to the Feilong code. This is kind of a high-level diagram. If you go to the homepage, the OMP homepage, and you go to the Feilong project landing page within the OMP, we go into a lot more detail on the architecture, and we break down the 3 different components. But I'm going to just quickly go through the 3 components on this one slide. And what you see in the diagram on the right, what's encircled or encapsulated in that square, those are the 3 pieces that make up Feilong. And we're going to work from the top down. So there's the RESTful API layer. It's Python-based. It uses a web server. It uses HTTP or HTTPS. You submit a JSON call to it, and you get back some JSON response and things like that. This RESTful API layer is this is a standard. This has been defined by Feilong. It's publicly available, so you can actually see all of the API calls. You can read about all the different API calls, how to program to them, and all that kind of stuff. And they even give you examples of how to interact with it. This layer is what can be consumed by a tool, say like OpenStack or VMware VRO, VRA, VRO. They can talk to this RESTful API layer and drive it and make it do things. And that's where I'm going to demonstrate here in just a little bit. Once the RESTful API layer receives a RESTful API call, so it's an Apache web server, an Nginx web server, it's going to do some basic checking of the call. It's going to make sure that it meets some criteria. And then if it meets all of that criteria, it's going to go down to the second layer in the diagram, which is the transition layer. This is where the heavy work is done, and that's why you see it as a much bigger box on the right-hand side. But that's where it takes the RESTful API call and says, and first of all says, do I understand what you're trying to ask me to do? And if I understand what you're asking me to do, then I need to translate that, and I need to basically pass it down to the lower layer, which is actually going to do the work. So this transition layer, again, is Python-based. So the upper 2 layers, easy to read, easy to write, easy to debug because it's Python. It's multi-thread aware. It's called by the RESTful API layer, the REST layer that's above. And it does basically the heavy lifting of making sure that whatever the request is, it knows what that request is, how to take care of the request. Once it understands all of that and has validated it, it passes it to the lower layer. The lower layer is called the SMCLI layer, also known as the ZHP layer. It is written in C, and it is what calls in ZVM terminology the SMAPI, the Systems Management API. So in ZVM, there is an API, SM API, but it's not so easy to interact with. What IBM has done is they've created this SMCLI tool. It's actually an executable that gets called with a whole bunch of parameters passed, and it actually tells SMAPI what to do, which tells ZVM what to do. Create a virtual machine, attach a network to it, create a disk, attach that disk to the virtual machine, all of those kind of things that I'm talking about. So the 3 layers have to work together. Now, as you build up a Feilong environment, you can start testing the different layers because each one can work independently of each other. But really, the power comes when all three layers are working together properly. The RESTful API is coming in, the request is coming in, it's getting processed all the way down to the lower layer, the work is being done, and then some response is coming back to the upper layer, and the receiver or the issuer of the request receives a JSON response that says, yes, what I did has been successfully completed. Make sense? Okay. Do you want to see it? Yeah, all right. Oh, before I'm going to show it to you, I'm going to actually show it to you in conjunction with IBM Cloud Infrastructure Center, that cloud product that I was talking about from IBM. And the reason why is because it has a really nice web-based interface. But under the covers, ICIC is OpenStack. OpenStack talking to the RESTful API layer. And so basically what you're looking at here is the diagram on the right is the OpenStack controller, the web interface that I'm going to interact with here in a second. And it's going to receive what I'm doing via web browser. And then it's going to send a request to Feilong, which in this case is highlighted as number 2, which is that kind of purplish looking thing. And then Feilong is going to work through SMAPI to tell ZVM what to do. Okay? Make sense? All right, let's show you how this thing works. I'm going to put my glasses on so I can see what I'm doing. Flip over here. So here is the IBM Cloud Infrastructure Center web interface. It's pretty straightforward. We use it within SUSE. And every SUSE employee has the ability to access this web interface as a self-service portal to create a virtual machine. And that's what we're going to do here, is I'm going to create a virtual machine. I'm going to, instead of playing the video, I'm just going to scroll through and I'm going to stop along the way. So this is the ICIC web interface, the IBM Cloud Infrastructure web interface. And I just wanted to show that here really quick. Now I'm going to go to a command line. Feilong really is infrastructure code. You never see Feilong itself unless you're really looking for it. But in this case, we're really looking for it. But to really see what it does, you have to go down to the command line. And I'm going to go here a little further. And remember that middle layer? Not the RESTful API layer, but the middle layer of the diagram, that is implemented in this thing called the SDK server. So the RESTful API layer receives the RESTful API request, does some basic processing, hands it down to the SDK server. That's what you can see, and I'm just basically doing a grep command for the SDK server, and you can see it's running on this Linux system, and this is the process ID and all that kind of stuff. So now I'm going to go a little further, and now I'm going to do a watch command. So this is a Linux thing, and I'll just explain it for those of you that may not be familiar with what watch does, but it will run this PS command, this PS-EF, I'm actually having it run it every second. So I'm just going to have it run every second, and it's just going to update the output on the screen. So if I start playing this really quick, you'll see how this works. It's just going to, see the numbers are updating. These two columns over here, these two columns are being updated. That's the process ID information, the parent process ID information. Every second that's being updated and right now the SDK server is not doing anything. It's just sitting there waiting to receive a request. So let's go a little further, a little faster. Now I'm going to go back to the IC web interface and I am going to create a virtual machine. So I'm going to go to my images, and because I work for SUSE, we're going to use a SLES image, a SUSE Linux Enterprise Server image. And it happens to be, I'm going to give it 2 virtual CPUs, 4 gigs of RAM, a 10 gig hard drive, so a very small hard drive. And then I'm going to give it some other information. I'm going to name it VM01. All right? So I'm going to go down and I'm going to hit deploy. And now what we're going to do is we're flipping back over to the terminal, and we're going to see SDK server doing something. Now, I'm not showing you what's happening at the RESTful API layer. I'm going to show you what's happening at the SDK layer. And now you can see that the SDK server has received some work to do. And if you look, it's calling SMCLI, the lower layer, and it's saying create an image. And it's creating an image, and it's naming the image. Basically, it's the ZVM guest name. It's called INS000 alpha 2. And it's going to go off and do some things. It's going to create a disk. And I'm just going to speed through some of this stuff. Once it's created those things, then it's going to bring that disk online. It's going to format the disk. And this takes a little bit to do. It's a 10 gig disk, so it takes a little bit to format it, but we're going to keep. And then I had told it in the web interface that I wanted a SLES 15 image to be deployed, a SUSE Linux Enterprise Server 15 image. So now it's actually taking an image and it's unpacking that image onto that disk that was just formatted. I'm sorry, what?
So the disk that you are actually writing it to, I mean, it's owned by a different virtual machine, right? So I'm assuming that you linked it.
Yep.
Behind the scene.
Yeah. So the question is the disk is owned by the virtual machine is being created. Is this disk being linked to another virtual machine to be able to unpack and deploy the image? The answer is yes, absolutely. That's what's happening. So what's happening behind the scene is some ZVM magic where you're able to link a disk to another guest, unlink it and link it to another guest, be able to do something to it, and then unlink it from there and link it back to yep, exactly. So this takes a few minutes to do. And all of this process, I'm spending a lot of time talking, but all of this happens in about 4 minutes. So just about like if you're familiar with deploying in a public cloud or anything like that, this process using IBM Cloud Infrastructure Center happens very quickly. You can see that the image was deployed. Now it's actually attaching let me go back, it's unpacked the disk. Let me scroll through, it connected the network adapter, and it's all done. Now if I go back over to the web interface, you can see that the virtual machine has gone from a state of being built to now active. I have an IP address that allows me to access it. There's the IP address that I'm highlighting. I can go over to another shell. I can SSH into that machine, pasting in the IP address that I've been given. Oh, well, it's still booting up. I'm actually faster. I was watching it pretty quickly. So the machine is still being booted. Here in a moment, it will be up. There you go. And I will SSH into it. And at this point, you can see it's named the virtual machine VM01. I can go over here. I can SU to root. And I think that's about it. So not a super snazzy demo, but I wanted to show you the two layers, the SDK layer, which is the middle, which does all the work, and the SMCLI layer, which actually talks to ZVM, talks to SMAPI, and actually does the real work of creating the virtual machine, configuring the disk, applying the image, connecting the network, starting the virtual machine, and all that kind of stuff. That all make sense? Cool. Any questions on the demonstration before I move to the last slide and wrap up the session? Good question, by the way. How am I doing on time? I think I'm doing pretty good. Okay, let me very quickly. So what's next for the project? So we are an incubation project. It takes effort. It takes people to get from incubation status to active status within the Open Mainframe project. What I really want is to get more people engaged in the project that we're willing to help to turn this into an active project within the Open Mainframe community. some of the areas, in addition to going from incubation to active, we want to help out with updating the project documentation, testing new features. The Feilong supports pretty much any major enterprise Linux distribution that runs on Z. So that's SUSE, that's Red Hat, that's Ubuntu. I do most of the testing of the SLUS related things, the SUSE related things, but more people doing more testing, we can find and make sure the features are working as intended. The summer mentorship project has been an amazing tool that the Open Mainframe project has taken advantage of. We, as a project, want to actually have a future summer mentor get engaged. We've had previous mentors. Actually, Vinny mentored a student a few years back. Hey, there you go. Awesome. Cool. Great. And did you work on the Feilong project? Different project. Different project. Okay. But Vinny did okay. And so we'd like to be able to do that again, focusing on things. And ultimately, like I said, I want to get in front of people and I want to get the word out through events like this. I presented at Share. I have recorded presentations. I try and get the word out about Feilong as much as I possibly can because we want to increase the Feilong membership. It's an active project. It can be heavily utilized. It's utilized by the Linux One Community Cloud, if you're familiar with that. If you want free access to Z resources, look up Linux One Community Cloud. And actually, that server is run within the Marist College data center, but it is free Z access, Linux on Z access to anybody. The open source community cloud also uses Feilong technology under the covers, and this is for more open source communities that want a permanent place to build their projects and stuff. But when I presented at Share last month, there was a good conversation that started. Right now, Feilong focuses on Linux deployments. What about second-level VM deployments? Could we do something and make it work for second-level VM deployments? And that discussion has already started within the project and within IBM and within other groups to figure out how we could maybe make that a possibility as well. So when the Open Mainframe project gets their own system up and running, they could maybe take advantage of Feilong to help manage that system as well. So if you're interested, we'd love to have you join Feilong. Pick a time that works best for where you live. And if you want to ask any additional questions, get on the mailing list. We're happy to answer those questions. And with that, I think I'm done. Any questions? Yes, sir. Yeah, so the question is there any plans for Ansible integration? So actually, the previous mentor, Vinny over here, and his mentee showed some Ansible integration, how they could integrate Ansible with Feilong and disk storage. Right, Vinny? Yep. So the short answer is it's all possible. It's just we need people that are committed to help the project that want to do that.
So those are all actually RESTful API calls, right? So for Ansible, you can just use a module to make a REST API call, right? So
yep.
I'm sure you can actually use Ansible right now with what you have over there.
Absolutely.
But it's easier to build a collection that is using the
Sure.
API instead of working directly with the API.
Right. And for the people online, sorry, let me just, so that everybody can hear. So the comment is you could use Ansible today to make RESTful API calls, and yes. I think your question, sir, was are there plans to have a library of Ansible, runbooks, basically, that could be used. And there's nothing stopping us. We just don't have the resources, the people resources to make that possible today.
Yeah, we definitely can wrapper them, right? Because they're just a bunch of commands, right? But we create playbooks. We
No, it wouldn't be. Thank you, Vinny. It wouldn't be that hard like Vinny said. So yeah, it's just a matter of taking time to get it done and prioritizing and getting more people engaged in the project. So hopefully you've learned a little bit about what Feilong is. Yes, sir. Sure.
Also regarding plans, we are working on Zoe, a game animation layer that is designed for concentrating or combining APIs.
Yep.
So is there any plan to work with
I hope so. When Len and Stephanie of IBM presented at the VM workshop, they intrigued some folks at Broadcom who had one of their developers join the project, and he's been at the meeting twice. And so he has already said he is looking at ways that he could actually maybe use Feilong in conjunction with Zoe. Yep, good question. Yes, thank you. Hopefully everybody online figured out what the question was, is basically any plans for Zoe integration. That was it, and then that was the answer. So, well, with that, thank you, everybody. Oh, one more question. Yes.
What is actually distro-specific about the Feilong server? My understanding is just
Yep.
translates REST calls to command line tool.
So the question is what's distro specific? So it's more on the imaging side. I didn't go into a lot of detail, but Feilong also can build images of Linux machines. So you can actually tell Feilong to capture a disk image. And it's the disk imaging part that is very distro specific. Otherwise, everything else is pretty much distro agnostic. The only thing is sometimes the libraries are slightly different between distros, and you may have to actually make a slight change in the code for the C portion, the SM CLI, to properly compile using GCC. Yep, good question. Yep, one more.
So those disk images, like SUSE, for example, so do you have your library ready to use by end users images like this, or it's up to the user to create their own?
No.
images?
So the question is are the disk images ready to use? And so within SUSE, I've built the disk images. So you can think of our implementation within SUSE as it's ready to go. It's like a public cloud. Literally, somebody goes to the web interface, they fill out the form, they say what version of the image they want, and they click deploy. It's all ready to do. Our users don't need to learn how to build an image. They just treat this as a cloud running on Z somewhere. Make sense?
So this is something that if I decide to try it on my own, can I download an image that you build?
I have documentation on how to build an image. Grab a card for me, and I'll happy to point you to my GitHub page where I tell you how to build the image. Okay? Yeah. Thank you. All right. Again, thank you, everyone. Have a good rest of your day today, and look forward to seeing you tomorrow.